All right, good morning, everybody. Okay, so to start off, I'm not going to be going quite into cosine law or sine law. What I'm going to be looking at is kind of ambiguous sine law today. This brings me to kind of two main rules that we're going to have to know for trigonometry in general. Okay, so rule number one, all three angles of any triangle have to be 180 degrees. So if you have a triangle here, you know that that angle plus that angle plus that angle is going to have to be 180 degrees. Okay, so we're going to be using this. And then rule number two that you have to know for trigonometry is kind of if you have a straight line there and you kind of intersect it with any other line, you know that one side of that intersection plus the angle of the other side of the intersection is going to have to add to 180 degrees. Okay, so we know that x plus z has to equal 180 degrees. So we're going to use this rule as well. So, okay, the last few diagnostics here is we have sine law, which is kind of what we're going to be working with today. It's a over sine A equals b over sine b. One thing to note here is you can flip the sides if you flip both of them at the same time, and it still holds true. One thing I can add to this equation here is we can also have little c over sine big C is really going to be the same ratio as well. And then this is the last piece of information. We have cosine law, which is another way to solve non-right angle triangles. All right, so what I'm going to be doing now is I'm going to be covering the types of triangles that you could possibly ever have. So any type of triangle, and you'll see that ambiguous sine law doesn't actually happen that often. So what we're going to do here is we're going to look at what types of triangles we can have. What combinations of triangles can we have? We know that we're going to have three pieces of information to solve a triangle. If someone gives you two, sometimes you can solve it, most of the time not. If you're given one, you definitely can't solve all three side lengths and all three angles of this triangle. Okay, so what's the first type of triangle? I'm just going to come up with one right now. Let's say they give you three side lengths of your triangle. So they give you a 12-foot, 11-foot, 13-foot. That's the dimensions they give you for that triangle. You can solve it. And this is the first type of triangle. It's a side, side, side triangle. And you solve it using cosine law. Okay. Again, we're not going to be solving that today. All right. So now into the second type of triangle. So we just did side, side, side. Let's look at maybe, what's another type of triangle that we can do? Maybe we can do a side and then maybe an angle and a side. This is called side, angle, side type of triangle. Side, angle, side because you have a side, and then you have an angle, and then you have a side length afterwards. Okay, kind of side, angle, side, or side, angle, side. Same thing. So this you solve using cosine law. So now here's the third type of triangle. This one, we're going to put an angle somewhere, and then we're going to put a side length, and then you're going to put another angle on the other side of the side length. So it's angle, side, angle. This is the third type of triangle. Again, angle, side, angle, or angle, side, angle. And this type of triangle, you can solve using sine law. All right, so the fourth type of triangle, we're going to have maybe an angle here, an angle there, and a side length there. Okay, so here we have angle, angle, side length. Angle, angle, side length. That is a different one. We haven't described an angle, angle, side length, so that's our fourth one. And this one can be solved using sine law. Now we move on to number 5. This one's the important one. This one is ambiguous sine law. Okay, so this one, angle, side, side, or side, side, angle. This one describes ambiguous sine law. And this is the only one that describes it. Okay, so if you have any other type, you know you won't have ambiguous sine law. And what does that mean? It means that you can have 0 triangles, 1 triangle, or 2 triangles. So angle, side, side. So angle, and this is how I'm always going to be representing it. Side, side. Okay, so I always put the angle on the left, and then the side up top, and the second side away from it. Okay, so that's angle, side, side. This is ambiguous sine law. And last of all, I might as well show all 6 types. What happens if you have angle, angle, angle? What if they give you those 3 pieces of information? So this one's a bit of a tricky one. Angle, angle, angle. This is the 6th type. This one's not really solvable. They have to give you a side length or a 4th piece of information to solve this. So this one is a unique case because it can scale to many different sizes. Okay, but that's beyond the fact. We're going to be looking at angle, side, side. We're going to be looking at ambiguous sine law today. Just that 5th case. I'm going to start off with this example here. So we have a triangle. This one you can see I've made up. It's a triangle here with 22 degrees in there. And then we have kind of no other piece of information. So we know we can't solve it. But what if they give us, say this, they give us, here we have 15, let's say, centimeters. And then here they give us, let's say, 17 centimeters. All right? So they give us this triangle here. What I'm going to denote is I'm going to say this is angle B by saying a big B. I'm going to have side length little b across from big B. And then I'm going to put big C as this angle in here. And then little c across from it. Okay? So the important piece to know is if you're ever given angle, side, side, or side, side, angle, you're going to have to put it in this representation. Or that's what I always do. I always make it or move around the triangle so that it looks like this, where you have the angle down here, you have the side length above it, and then you have the second side length kind of going down like that. Okay? You can always move it so that it's like this. So now we have, this is our triangle, and what we're going to do is we're going to solve for this side length here. So what we're going to do is we're going to solve using sine law by multiplying by 15 and using inverse sine, and we'll eventually get to 19.3 degrees as our C value for our triangle. Okay, so this in here is going to be 19.3 degrees. Okay, 19.3. I know that's hard to read. That's 19.3 degrees. With ambiguous sine law, you have to ask yourself, oh, is there a second triangle that it could possibly be? But when you look at this, how it works is you swivel this gray line and it's not able to make it. So this is case 1 where you have your triangle where you have the second side length longer. This 17 is longer than this one here, this B, this C value of 15. Okay, so this length here is longer than this one. You know you're going to have one triangle only. Okay, so in this example we have 19.3 degrees and we know we can solve the rest of the triangle. Since this 17 is bigger than this 15, we know that we're going to have only one triangle. Okay, so only one triangle. And the reason why is because 17 is bigger than 15, or this side, B, is bigger than C. Okay, so if you ever have the second one away from this angle, and it's bigger than the first one, you know you're going to have just one triangle. Okay, and it's at 19.3 degrees. We could solve the rest by using sine law here. Here is example number 2. Say you have a triangle and they give you the piece of information where one side length is, again, 15 centimeters and the other side length is 5 centimeters. Okay, so they give you a new triangle where one side length is 15 centimeters and the second side is 5 centimeters. Okay, this is the second case. If you look at how I drew it, this is actually 15 centimeters, this is actually 5 centimeters, and it doesn't actually reach this bottom line. Okay, so sometimes the second angle can be way too small to actually reach it to the bottom there. And if that's the case, there's going to be no triangles. Okay, how do you know that when you're solving a problem? Well, you still try to solve it. Okay, you don't know that it doesn't touch there in your problem. So what you do is you'll solve it like so. You'll again times by 15. You'll inverse sine, and you'll end up in your calculator with an error domain or a domain error in your question, and this means essentially that there's no triangles. And your one side length here is too short to actually complete your triangle. Okay, and there's no way, because that angle has to be 22, to make it so that it will touch that line. Okay, so this is the second type of example where your second one is way too small compared to your first side length. Okay, but again, it's still angle side side. So here is our third example. So this one here is I guess the main part with ambiguous sine law, where they give you information and it could be two triangles. Okay, so here we have kind of the example here. You see this weird triangle. I'm going to set it aside for now, and this is our example here. They're given 22, and they also say the angle beside, or the side beside that angle is 15 again, but this time this one over here is 11 centimeters. Here, if I look at it, I'd again try to solve for this angle. So you're saying, what's the big deal? So I'd solve it like so. Okay, and my C value using sine law would be 30.7 degrees. Okay, so let's put that in for this side length here, 30.7 degrees. All right, so there you have it. Then you could solve the rest of the triangle. But you're saying, how do you know it's ambiguous sine law? Well, because it's angle side side, and this side length is smaller than this one, but not too small that it doesn't make a triangle. So you know that there's going to be two triangles. But the problem is, how do you get the other one? Okay, so theory-wise, you take this gray line here, you pivot it right here, and pretend the pencil is that gray line. And what you're going to do is you're going to pivot it around until you hit that brown line again. There. Okay? So you pivot it like so, just like that, and that'll make you your new triangle here. Pull it away. So this triangle here still has the same information. Still has 22 degrees, 22 degrees. Still has a 15, that blue line, and still has an 11, that gray line. So everything stayed the same, but it's another triangle that you can make for ambiguous sine law. So again, I'm going to write 11 here this time. So we're going to have 15 and 11. So this time is a second triangle that you can make with that information of angle side side. Okay, 11 again is not bigger than 15, but it's not too small, right? So that's our second triangle there. And if you want to see kind of the example of it, those are the two triangles here. So we have ambiguous sine law here. You have your first triangle, which is this one, and you have your second one, which is this one here. Okay, so those are our two triangles that we make for ambiguous sine law. Okay, so usually you have to solve both of them for what their angles is, right? So this one we found out was 30.7 degrees. Okay, so you take that 30.7 and we can write it right there. And then what we're going to notice is this dotted line is the same length as that dotted line. And with that, then this inner triangle we know is going to be isosceles, which means that that angle is actually the same as that angle. Okay, this one right here. Okay, so now that you have that, you can see 30.7, 30.7. We want to find out what this angle is here. Okay, and to do that, we bring in rule number 2. Rule number 2, x plus z has to be 180 degrees. So that means, again, if we have this dotted line going through, this plus that has to be 180 degrees. Okay, so if I want to solve what this is, or specifically this triangle here, what that angle is, we're going to have to do this. Okay, where we go 180 minus 30.7, which was our angle from our first triangle. Okay, so here we get 149.3 as our angle, 149.3, and that's actually what our angle is right here, 149.3 degrees. Okay, and then we could solve both triangles using sine law for getting that angle and that angle afterwards. Okay, solving them separately as 2 different triangles. Quick recap, we did a first example where one side length was longer than the first side length, and that makes it so that you only have one triangle. We had a second example where this gray line was actually too short to make it to that brown line, and that means there was no triangles. So that means this was too short than kind of this line here from here to here. Okay, and we'll call that H. Okay, so this gray line was shorter than H. Okay, and then last of all, we had kind of a mixture where this gray line was longer than H, but shorter than that blue line. Okay, and that's where you get 2 different cases. Okay, so let's try an example. First of all, it says solve the triangle where you have big A, which is 40 degrees, little a, which means across from that angle, is 17 centimeters, and then we have this C, which is 10 centimeters. So how do you draw it? How do you get started? What I do is I draw all my triangles like this one there. Okay, it doesn't have to be quite accurate, but that's okay. So I'm going to draw a triangle here. There we go. Pretty good, right? I have my triangle. I'm going to put 40 degrees always in this corner here. Okay, 40 degrees. And then I'm going to have angle. This is A, this is little a, so I'm going to put that 17 centimeters across from it because it kind of has to be. Okay, and that means the C, I'm going to put it, it's okay that the letter's different, but I'm going to put that 10 centimeters right here. Okay, because I know I'm going to have angle side side, and the way I represent these triangles is I always need the side lengths to be up there and over there. Okay, so if I label it, I'm going to have A, this one I'm going to go C, C, and this one must be B and B. Okay, so that's my triangle there. Okay, it says solve the triangle. There I have it. Okay, so how do I solve it? Well, first things first, I look at this. 17 is bigger than 10. Okay, first of all, I have angle side side, which means it can be ambiguous, but this 17 is bigger than this 10. Okay, so this 17 is bigger than this 10, which means must be only one triangle. Okay, has to be, because that's bigger than that. Okay, so it's a pretty easy one. So now I can just use sine law, and I can solve it. So let's solve it. And we get a side length of 23.4 centimeters. All right, so that's the answer to that one. It's just a sine law. It is an ambiguous sine law, but since 17 is bigger than 10, it's only one triangle. All right, so let's try the second example. Here I've started to draw, again, the same triangle, and we have this information here. Okay, so C is 51 degrees. We have the little c across of it is 10 centimeters. And then B I'm going to put in between because I need ASS. Okay, if I put it down there, it still would be ASS, but I want to put it up there so that all my triangles are the same. All right, so we have 51 degrees, 12 centimeters, and 10 centimeters. Okay, so one thing you notice here is this is smaller than this. Okay, so we know it's not just the one triangle. So the question is that 10 centimeters going to be smaller than that h value there? Is that 10 centimeters going to be smaller than that h? My guess is it's not going to be. Okay, if it was smaller than that h, we'll get an error anyways, and it'll tell us there's no triangles. But we know, or we'll see if it's no triangles or if it's going to be 2. Okay, so let's do the math. All right, so we get a value of 68.8 degrees in there. So we know there's going to be 2 triangles, okay? The reason why is because 10 is less than 12, and we didn't get an error message, okay? So B is 68.8, okay? So what does that lead us to? It leads us that there's going to be another triangle, okay? And it's going to look like that weird one, like that, where you take this line and you drag it over here, okay? This is, what's the other triangle there? Okay, this is our new triangle here. So since that's 68.8, that means this is going to be 68.8. All right. So now we have to find out what this is, okay? This is C, this is B, and this is A. So we have to solve what that is. How are we going to do it? 180 minus 68.8. So we have one triangle here, and then we have our second triangle there. Okay. Again, we could solve for A like so. All right, so now we can solve for little a and little a there using sine law with the 60.2 for this triangle and using sine law with the 17.8 for this triangle. All right, so example 3. So this one here, one thing is it's not written how the other ones were written. Sometimes they give you examples like this. It's not drawn to scale either. So sometimes they can show you a triangle and it's not actually how it actually looks. They're just saying the numbers are true, but not actually the drawing. So here we have angle, side, side. So we know that it can be ambiguous, but it's not drawn how we normally like to draw it. Okay, so here I have 38, 60, and 100. So let's try to draw it the way we normally draw it. Okay, so what I'm going to do is I'm going to draw a triangle like I normally draw my triangles. I'm going to put the angle still in that bottom left hand side. Okay, but I'm going to move that 100 up here. Okay, but you might think, does that change the triangle? And you have to do it carefully. Okay, so I move the 100 up there. So 100 in the first example was beside the 38. So here it's still beside the 38, so I haven't changed it. This 60 is across from the angle and beside this side. So that means I have to put it here. So now it's still angle, side, side, angle, side, side. This is still across the angle and beside the side length. So I didn't actually change it. What I actually did is I kind of flipped the triangle. Okay. So now I have it in my drawing that I like, and so here I can try it out. I'm going to solve for this angle here, B. We get an error domain. That makes it so that there's no triangles. So in this example here, must mean it's not a possible triangle. And how we did it is we rearranged it to the form that we like, and we look at this, and this 60 must be too small to actually make the triangle with a 38 degrees there and 100 there. Okay, what it means is if I draw a straight line down and call this h, it means that this h value that we would get must be larger than the 60. Okay, it's not drawn that way, but again, the drawing might not be accurate. So the length might actually only be this long, and when you swivel it, it won't actually reach this line down there. So we will say that there's no triangles possible to make with whatever this person gave you. They said make a triangle with 38 degrees, 160 in the form ASS, and you're saying it's not possible. All right, so let's recap what ambiguous sine law is. So we know that there's 6 different types of triangles. Okay, so if I have a triangle, you can fill in 3 pieces of information, and you most likely will be able to solve it. So these are the ones you have: SSS, SAS, ASA, AAS, ASS, and AAA. Okay, so really we just focused on number 5. Okay, because all the other ones are pretty straightforward to solve. But when you hit angle, side, side, you know that it can be no triangles, it can be 2 triangles, or it can be just 1 triangle. Okay, so let's recap when it is each. If ASS type triangle, then you can consider it maybe being ambiguous because it can be 0, 1, or 2 now. Okay, if it was any other type of triangle, you'd be fine. Okay, number 2. If, say, you have an angle here, okay, if the second length is larger than this one here, you know it's just going to be one triangle, and you know you're going to be able to solve it using just sine law. Okay, so then you know just use sine law, and whatever you get is the triangle, because there's only going to be one. Okay, so that's if this length is longer than this one. Okay. Number 3. What else did we find? Well, is if your second length, the second one here, is shorter than h, okay, is shorter than that h length, and you'll never actually be able to reach this bottom line, and you won't be able to make a triangle. Okay, so if it happens that this length is shorter than h, there'll be no triangles. And how we solve it is we just try to do sine law, and we get an error message. And that error message tells us it's too short. All right. Last of all, if two triangles are possible, that is, this length is shorter than this length, but longer than h, so kind of in that sweet spot, there are two possible triangles that exist, or that can exist, okay? So if someone asks you, with this information, give me the triangle, you'll say, no, there's actually two triangles. And the triangles are these two here, okay? So you draw it our normal way, or you can swivel that gray line till it reaches back along this brown line, and you get this triangle here, okay? These are our two possible triangles. And it could be either, okay? So you can solve it using sine law, and you'll always get the angle here. And then you can go 180 degrees minus that angle to get the angle for your second triangle. Okay? And that's ambiguous sine law. Good luck. Thank you. Please enter in the comments below what I could have done better, or any questions that you have, or any other math concept that you'd like me to cover. Thanks.